In this video, I'm going to do a few more examples of factoring trinomials with a leading coefficient of 1. I want to show you some special cases that we need to be on the lookout for. And the first one would be where your leading coefficient is actually a negative 1. In order to use the method that I showed you in my previous video on factoring trinomials with a leading coefficient of 1, we cannot even have this negative here in the front. So anytime we have our first term negative, we want to go ahead and factor out a negative 1 so that we'll be left with a trinomial that does in fact have a leading coefficient of positive 1. So I'm going to factor out a negative 1, which essentially is going to change the signs of everything in the trinomial. Now I'm looking here at what's left in the parentheses, and I see I do have a leading coefficient of 1. So now I can carry on with the method that I showed you in my previous video and find the factors of positive 35 that add to get positive 12. And so those are going to be positive 7 and positive 5. So this is going to factor to y plus 7 and y plus 5, and this negative 1 will still be out front as part of our answer, because the only way we would end up back with this that we started with is to distribute these out and then multiply everything through by that negative 1. Alright, let's look at another problem. 30y cubed plus 2y to the fourth plus 112y squared. Well, you might take a look at that and you might say, well, that doesn't have a leading coefficient of 1. No, it doesn't, not currently. In fact, we've got a couple of things wrong here that we need to fix before we can proceed. We need to put our terms in order by descending powers of the variables. So the highest power of y that I see is y to the fourth. So that term needs to go first, 2y to the fourth. Then the 30y cubed. And last, the 112y squared. Now that I've got them in order, I want to do what I really should look for in every factoring problem. I want to factor out a greatest common factor. Any factoring problem, that should be our first thing that we are on the lookout for, is to see if we have a greatest common factor. And if we do, it needs to be factored out first. So we do in fact have one. These are all even numbers, so I know I can factor out a 2. I also see that these all have y's, so I can factor out a y squared, because that's the lowest amount of y's I have in a term. And that's going to leave me with y squared plus 15y plus, what's half of 112? Well, I can split 112 up. Half of 100 is 50, and half of 12 is 6. So half of 112 is 56, and that's what dividing by 2 is the same as, like taking half of something. So this is going to be 56. Alright, now that I've factored out that 2y squared, that greatest common factor, I've got a trinomial with a leading coefficient of 1. And so I can look for my factors of positive 56 that add to get 15. It looks like it's going to be positive 8 and positive 7. So this is going to factor to y plus 8 and y plus 7, and we'll also bring down the 2y squared as part of our final answer. Alright, let's look at another one. We've got negative 40x minus 30x squared plus 10x cubed. Alright, once again, my terms are not in order, and so I want to go ahead and put them in order first by descending powers of the variable. I'm going to put 10x cubed first, then minus 30x squared, then minus 40x. I'm going to look for a greatest common factor for all three terms. 10, 30, and 40 are all divisible by 10, and I also have at least one x in all three of these terms, so I can factor out a 10x. That's going to leave me with x squared minus 3x minus 4. Once I've taken that greatest common factor out, I've got a trinomial with a leading coefficient of 1. So I'm looking for factors of negative 4 that combine or add to get negative 3. That's going to be a negative 4 and a positive 1. So this is going to factor to x minus 4 and x plus 1. And we will also bring this 10x down as part of our answer. Okay. Let's do one that has multiple variables in it. That's a C, guys. Alright, we got C's and D's in here. Now, if we go to put this in order, a lot of people say, well, how do I know if that's in order? Well, if you have multiple variables, you can only put it in order with respect to one variable. This is currently in order with respect to C because my C's are in order by descending powers. C squared and then C, and then this one doesn't have any C's. You could swap it around and put it in order with respect to D, but there's no need to do that. As long as it's in order with respect to one of the variables, we should be good. Now we'll look for a greatest common factor. I know these are all even, so I know I can take out a 2. I also see that my first term is negative, and I don't like that. So when I factor out my 2, I'm going to go ahead and factor out a negative 2 so that my first term no longer has a negative leading coefficient. If I take out a negative 2, I'm going to have c squared. If I divide this by negative 2, it's going to be positive 11cd. And if I divide this by negative 2, it's going to be positive 30d squared. Now, in my last video, we did a problem like this. It does have a leading coefficient of 1. So essentially you do it the same way. We just have that extra variable in there. And I'll remind you what to do with that. We're looking for factors of 30 that add to get positive 11. Those are going to be positive 6 and positive 5. We'll bring this negative 2 down. C squared is going to come from C times C. Our two numbers we chose are 6 and 5, but this last term has a D squared on it. So we will need those to be a 6D and a 5D. Order that you put them in does not matter. Alright, one more problem like this. X cubed, y cubed minus 19x squared y cubed plus 60xy cubed. Okay, so once again we've got multiple variables. We can only put it in order with respect to one variable. This is currently in order with respect to x, so we're good on that. We want to look for a greatest common factor. These do in fact all have x's, so I can at least factor out an x, and they all have a y cubed. So in addition to that, I can factor out a y cubed. So I'm factoring now a greatest common factor of xy cubed. That's going to leave from this first term x squared. From the middle term, it's going to leave minus 19x. And from the last term, it's going to leave plus 60. All right, after all that, you see that what's left here is a trinomial with a leading coefficient of 1. So I'm looking for factors of 60, positive 60, that add to get negative 19. All right, so factors of 60. We know 1 and 60. Now we do know they've got to either both be positive or both be negative. Since this is negative, that means they're both going to have to be negative. So negative 1 and negative 60, no. Negative 2 and negative 30, that's not going to work. I know 6 and 10 multiply to get 60, that's not going to work. All right, so if you get hung up and you can't think of any more, remember I taught you a double and half trick, or half and double. It doesn't matter. You can take any pair of these factors. You can half one of the numbers and double the other, and it will give you another pair of factors. So let's try that. For 6 and 10, I could half the 6 and double the 10, and that will give me 3 and 20 as an option. I could, let's do another one. How about the 2 and the 30? I could double the 2 and half the 30, and that would give me 4 and 15. Now I'm just adding these negative signs because we've already determined that they're both going to have to be negative. This is actually one that works. For -4 and -15. Multiply to get positive 60 and add to get -19. So this is going to factor to x minus 4 and x minus 15. And we'll have this xy cubed out front that we factored out to begin with.